Ever feel like your AI workflows need a traffic cop to direct requests to the right destination? You'll see how to build a dynamic router that examines user input, then intelligently routes it to generate either a joke, story, or poem, all using structured output and conditional logic to keep everything clean and maintainable. The pattern uses LangGraph state management to pass decisions between nodes, showing how to chain specialized tasks without hard-coding paths. By the end, you'll have a reusable template for routing-based workflows that adapt to different input types. From typing extensions, import literal. From LangChain, messages import human message, system message. Hash schema for structured output to use as routing logic. Class route, base model. Step, literal poem. Story, joke equals field. None, description equals the next step in the routing process. Hash augment the LLM with schema for structured output. Router equals LLM with structured output route. Hash state. Class state type dict. Input, SDR. Decision, SDR. Output, SDR. Hash nodes. Def LLM call one state, state. Write a story. Result equals LLM, invoke state input. Return, output, result content. Def LLM call to state, state. Write a joke. Result equals LLM, invoke state input. Return, output, result content. Def LLM call three state, state. Write a poem. Result equals LLM, invoke state input. Return, output, result content. Def LLM call router state, state. Route the input to the appropriate node. Hash run the augmented LLM with structured output to serve as routing logic. Decision equals router invoke. System message. Content equals route the input to story, joke, or poem based on the user's request. Human message. Content equals state input. Return, decision step. Hash conditional edge function to route to the appropriate node. Def route decision state. Hash return the node name you want to visit next. If state decision equals story. Return LLM call 1. Elif state decision equals joke. Return LLM call 2. Elif state decision equals poem. Return LLM call 3. Hash build workflow. Router builder equals state graph state. Hash add nodes. Router builder add node. LLM call 1, LLM call 1. Router builder add node. LLM call 2, LLM call 2. Router builder add node. LLM call 3, LLM call 3. Router builder add node. LLM call router, LLM call router. Hash add edges to connect nodes. Router builder add edge start. LLM call router. Router builder add conditional edges. LLM call router. Route decision. Hash name returned by route decision. Name of next node to visit. LLM call 1. LLM call 1. LLM call 2. LLM call 2. LLM call 3. LLM call 3. Router builder add edge. LLM call 1 end. Router builder add edge. LLM call 2 end. Router builder add edge. LLM call 3 end. Hash compile workflow. Router workflow equals router builder compile. Hash show the workflow. Display image router workflow get graph. Draw mermaid PNG. Hash invoke. State equals router workflow invoke. Input. Write me a joke about cats. Print state output. This demonstrates a dynamic routing pattern in workflow orchestration.
where a single entry point intelligently directs requests to specialized processing nodes based on content analysis. The key concept is conditional branching driven by structured LLM output, allowing the system to make runtime decisions about which execution path to follow. What makes this distinctive is the separation between routing logic, which analyzes intent, and processing logic, which executes the specialized task, creating a clean division of responsibilities. The pattern works by first classifying the input using a constrained LLM output schema, then using that classification to select the appropriate processing node. This declarative approach lets you define routes as data rather than hard-coded logic, making the workflow more maintainable and adaptable. The routing decision becomes a first-class citizen in the system state, enabling complex workflows where the path isn't known until runtime, while still maintaining a clear, linear code structure for each possible branch. This approach solves the problem of monolithic, one-size-fits-all processing by enabling specialized handling for different input types. It's particularly valuable when you need to support multiple distinct operations through a single interface, like a chatbot that can generate different content types or an API that processes varied requests. The trade-off is slightly increased initial complexity in setting up the router, but this pays dividends as you scale to more routes or need to modify individual processing paths without affecting the overall system architecture. Let's break it down.
From typing extensions, import literal.
Imports literal from typing extensions to enable strict string literal type checking. This ensures the root class only accepts predefined values like poem, story, or joke, preventing invalid routing decisions.
Hash augment the LLM with schema for structured output. Router equals LLM with structured output root.
This augments the base LLM with structured output capabilities using the root schema. The enhanced router instance will now return strictly typed decisions, poem, story, or joke, instead of free-form text, eliminating ambiguous routing logic.
Hash state. Class state type dict. Input, SDR. Decision, SDR. Output, SDR.
The state type dict defines the workflow's data structure with three keys: input, user request; decision, router's content type choice; and output, final LLM response. Each node returns partial updates, e.g., decision, joke, or output, that merge into the state, enabling lightweight, incremental state management focused on routing logic.
Def LLM call one state. State. Write a story. Result equals LLM. Invoke state input. Return output. Result content.
This is the story writing node in the workflow graph. It takes the user's input from the state, passes it to the LLM, and returns the generated story content in the output field. The pattern is identical across all content generation nodes, only differing in their declared purpose.
Def LLM call to state. State. Write a joke. Result equals LLM. Invoke state input. Return output. Result content.
This implements the joke writing node in the workflow graph. It follows the same pattern as other content nodes, takes user input, delegates to the LLM, and returns the result in the standardized output format. The consistency ensures predictable behavior across all content generation paths.
Def LLM call 3 state. State. Write a poem. Result equals LLM. Invoke state input. Return output. Result content.
This is the poem writing node in the routing workflow. It follows the same pattern as the other content nodes, taking the user input, passing it to the LLM, and returning the generated poem in the state's output field. The consistent structure across nodes enables predictable workflow behavior.
Def LLM call router state. Route the input to the appropriate node. Decision equals router invoke.
This defines the router node that determines which creative path to take. It uses the structured output LLM we configured earlier to analyze the input and decide between story, joke, or poem, then passes that decision downstream. The router invoke call takes both a system prompt defining routing rules and the user's input as messages. This is the Lang chain pattern for structured LLM interactions.
Def route decision state. If state decision equals story, return LLM call 1.
This conditional routing function determines which content generation node to execute next. It checks the router's decisions stored in state, mapping story to the story writing node, ensuring the workflow follows the correct path based on user intent.
Hash build workflow. Router builder equals state graph state.
Initializes the workflow using Lang chain's state graph. This is the foundation for building stateful, multi-step AI workflows where each node processes data and passes it to the next. The state type dictionary defines the data structure that flows between nodes.
Router builder add node. LLM call 1, LLM call 1. Router builder add node. LLM call 2, LLM call 2.
Registers the 3 content generation nodes with the workflow builder. Each node represents a distinct LLM call path, story, joke, or poem, enabling the router to delegate work based on the routing decision. This modular design keeps generation logic isolated while maintaining a clean workflow structure.
Hash add edges to connect nodes. Router builder add edge start. LLM call router.
This establishes the workflow's entry point. The start node automatically routes all incoming requests to the LLM call router node first, ensuring every input gets classified before processing. This is the standard pattern for defining workflow initiation in state graphs.
Router builder add conditional edges. LLM call router.
This begins defining conditional routing edges from the router node. The conditional edge pattern dynamically determines the next node based on runtime state, enabling decision-based workflows instead of linear execution.
Router builder add edge. LLM call 1 end.
This defines the terminal edge for the story writing node. After LLM call 1 completes, the workflow ends, preventing any further processing. This mirrors the pattern used for all content generation nodes in the graph.
Router workflow equals router builder compile.
This compiles the state graph into an executable workflow. The compilation step validates all nodes and edges, ensuring the workflow is properly connected and ready for execution. Without this, the graph remains just a definition, not a runnable process.
Hash show the workflow. Display image router workflow get graph. Draw mermaid PNG.
This visualizes the workflow graph using mermaid.js. The Draw Mermaid PNG method generates a diagram showing all nodes, edges, and routing logic, making the execution flow immediately clear, critical for debugging complex workflows.
Hash invoke. State equals router workflow invoke input. Write me a joke about cats. Print state output.
This executes the workflow with the input, write me a joke about cats. The router determines this should go to the joke node, and the final output is printed, demonstrating the complete routing flow from input to specialized LLM call. LangGraph routing pattern. This implementation demonstrates dynamic workflow routing using structured LLM outputs, where the root class with literal types enforces strict decision paths, while human message carries user input through the system. The state dictionary must maintain consistent keys across all nodes, as missing or mismatched keys will silently fail rather than raise errors during execution. By separating routing logic, LLM call router, from execution nodes, LLM call 1/2/3, you create a maintainable system where new content types can be added without modifying existing decision logic.
The router that chooses no path finds every destination.